Hi, this is Rakesh Gupta, and this is my take on question 4 of end-term video assessment.
So let's start by seeing what we have in the question. So we have a non-homogeneous linear ODE, which is given by this equation. And so as we know that the linear combination of two solutions, it gives the general solution to which the general solution is given by the linear combination of these two solutions, where YH, this is H, this is the solution for the homogeneous part, and this is called the particular solution. Now let's start by solving for the homogeneous part. So the homogeneous part of this given question is going to be y double dash plus 9y equal to 0. So now what we are going to do is assume y to be an exponential function. Therefore we get, when we differentiate y with respect to x, we get y dash is equal to x times of e power lambda x, and y double dash is equal to sorry, this is going to be lambda times lambda square e power lambda x. So now we substitute these values in the homogeneous part of the question. We will then get we'll take e power lambda x common. So as e power lambda x cannot be 0, an exponential part cannot be 0, so therefore lambda square plus 9 is equal to 0, which then gives us the value of lambda as plus minus 3i, where I is also referred to as iota, and the value of which is given by under root minus 1. So now if you see the general form of a complex number, it is, let's just write it as alpha plus I beta. So writing this, writing lambda in the general form, we are going to get it as 0 plus minus 3i or I3. It's the same thing, doesn't matter. So here alpha is 0 and beta is 3. So the solution will now be given by, we are finding out the homogeneous part. It is going to be given by e power alpha x multiplied with a cos beta x plus b sin beta x. Now we know the values of alpha and beta, so we substitute them in this equation. So e power alpha is 0, so this is going to be e power 0, which is 1. We're going to get it as a cos 3x plus b sin 3x. This is the solution for the homogeneous part. Now we will have to solve for the particular solution. So in the question, it has been mentioned that we are supposed to solve using variation of parameters or undetermined coefficients. I'm going to use Lagrange's method of variation of parameters. to find out yp, the particular solution using variation of parameters, it is nothing but so this is basically the formula of what we are going to use for solving the question. Now over here y1 is nothing but y1 is nothing but cos 3x and y2 is nothing but sin 3x, and r of x as given in the question is cosecant of x. So r of x is cosecant of x. So now the question is what is w? So w is I don't know how to pronounce this, so I'm just going to write this. So this determinant is given by, so we already have y1 and y2. So y1 dash, when we differentiate with respect to x, we're going to get minus 3 sin x, and when we differentiate y2 with respect to x, we are going to get 3 cos x. Substituting the values of y1, y2, y1 dash and y2 dash in the determinant, we are going to get uh, sorry, this is going to be 3x. Sin 3x, y1 and y2 is 3 cos 3x. Now when we solve the determinant further, we'll get cos 3x multiplied with 3 cos 3x subtracted by sin 3x multiplied with minus 3 sin 3x. So it is 3 cos square 3x plus 3 sin square 3x. So according to the identity sin square x plus cos square x equal to 1, we just take 3 common out of here, and we get cos square 3x plus sin square 3x, which is going to give us 1. So we have the value of w as 1. So now we substitute the value of w, the values y1, y2 and rx into this equation right here, yp. So I'm just going to write the entire thing down again. R of x, I'm just going to write it as r for convenience. We have y1 given as cos 3x, y2 as sin 3x, and we know that r of x is cosecant x. and we have found out w to be 3. Y2 is sine 3x, then integral y1 is cos 3x multiplied with cosecant x divided by w, which is 3 dx. So now, because this equation is really long, so I'm just going to term this thing as 1 and this thing as 2, so that it's easier to solve when I solve 1 and 2 separately. It's easier to write. So I'll continue now. We're solving for 1. Minus cos 3x. I'm just going to take the denominator in 3 outside, as it does not involve any x. So we can write sine 3x. There is a formula which goes like sine 3x is equal to 3 sine x minus 4 sine cube x. This is an identity, a trigonometric identity. So I'm just going to write it that way. Now I'm going to multiply, well, as you know that cosecant x is nothing but 1 by sine x. So this is just going to give us 3 when I multiply 3 sine x with cosecant x, and when I multiply 4 sine cube x with cosecant x, I'm going to get 4 sine square x, as one of the signs in the numerator gets cancelled with the sign in the denominator. Now we solve further. Integral of 3 with respect to x is nothing but 3x. Now the integral of sine square x. Actually, I'm just gonna go slightly back over here. So what I'm going to do is write. Uh, First, let me write this. I'm going to write sine square x as 1 minus cos 2x by 2 dx. Cancel 2 with the 4 and it becomes 2. So 3 minus, so when I open this bracket, I multiply 2 with 1 and then 2 cos 2x. So I get 1 minus of minus, which is 1 plus 2 cos 2x dx. Now when I integrate, I have this is a bracket. So one integration of 1 with respect to x is x, and when I integrate 2 cos 2x, I'm going to get 2 sine 2x by 2. This 2 and this 2 get cancelled, and then I'm left with this. So this is the solution for 1. Now we'll have to solve for 2. Equation 2, part 2 is given by sine 3x multiplied with, okay, sine 3x, again I'm going to take 3 outside, multiplied with cos cos 3x cosecant x dx. Cos 3x cosecant x dx. So now I'm going to write cos 3x as 4 cos cube x minus 3 cos x. This is an identity again. Cosecant x dx. Now I just open up the brackets, and I'm writing cosecant x as 1 by sin x. So now one of the cos from cos cube x when divided by sin x becomes cot x. So I can write this as 4 cot x cos square x minus 3 cot x. Now when we solve further, so what I'm going to do now is that add and subtract cot x from this expression. So minus 3 cot x, and I'm now going to add and subtract, plus cot x minus cot x. So now what happens is this minus cot x and this minus 3 cot x becomes minus 4 cot x. Then I take 4 cot x common, write it as cos square x minus 1 plus cot x whole thing dx. Now cos square x minus 1, as we know that 1 minus cos square x is sin square x, so this is going to be minus sin square x. So cot x we know, just a minute. So we know that cot x can be written as cos x by sin x. So one of the sin x from the numerator over here gets cancelled with the one in the denominator. So we have 4 cos x minus 4 cos x sin x plus cot x dx. So we have another formula which I'm just going to write it over here. It says sine 2x is equal to 2 sine x cos x. I'm going to use this one over here and write this as minus 2 sine 2x. Compare this to this plus cot x dx. Now I just integrate. So the integral of minus 2 sine 2x is going to be 2 cos 2x by 2. And we know that the integral of cot x is nothing but ln of sin x. Sorry, the constant of integration should be there. I must have missed it out over here also. Yep. Okay, so now we have our second part also. Now we can write the entire particular solution as 1 plus 2. Our first solution is given by minus cos 3x by 3 plus the second part, which is over here. So this is a particular solution plus c, the constant of integration. So we have our particular solution now using all these steps. So now, if you recall, our general solution y was given by this equation right here. So particular solution plus the homogeneous part. So we have homogeneous part after solving as a cos 3x plus b sin 3x. Just going to write it. General solution y is equal to homogeneous part plus the particular part. So homogeneous part was a cos 3x plus b sin 3x. Now I'm going to add the particular part, which is over here, right over here. I'm just going to write this term first. Minus this term plus sin 2x plus the constant of integration c. So now we have our final solution for the question. That is all. Thank you.